Determining whether a room containing a sealed sewage tank and pump is a Class 1, Division 2 location requires careful consideration of the potential for flammable vapors to be present. The National Electrical Code, or NEC, defines a Class 1, Division 2 location as an area where flammable liquids or vapors are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment. Also included are locations in which flammable liquids or flammable gases are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment. In the scenario presented, the sealed tank containing sewage presents a potential source of flammable vapors. While the tank is designed to be sealed, the possibility of a leak developing exists. If a leak were to occur, flammable vapors could be released into the room. To mitigate this risk, an exhaust fan is in place to provide constant ventilation. The purpose of the exhaust fan is to prevent the accumulation of flammable vapors by continuously removing them from the room. However, the exhaust fan itself is a piece of mechanical equipment that is subject to potential failure. If the exhaust fan were to fail, the flammable vapors released from a leaking tank could accumulate, creating a potentially hazardous atmosphere. Given these factors, it is reasonable to conclude that the room is likely a Class 1, Division 2 location. The potential for flammable vapors to be present, even if only in the event of a tank leak or exhaust fan failure, satisfies the criteria for this classification. The NEC mandates specific requirements for electrical equipment installed in Class 1, Division 2 locations. These requirements are designed to minimize the risk of ignition in a potentially explosive atmosphere. One of the primary requirements is that all electrical equipment installed in a Class 1, Division 2 location must be explosion-proof or intrinsically safe. Explosion-proof equipment is designed to contain any internal explosion within its enclosure, preventing it from igniting any flammable vapors in the surrounding atmosphere. Intrinsically safe equipment, on the other hand, is designed to operate with such low energy that it cannot produce a spark or thermal effect that could ignite flammable vapors. In addition to explosion-proof or intrinsically safe equipment, the NEC also requires that all wiring and cabling in a Class 1, Division 2 location be installed in rigid metal conduit or be specifically approved for use in hazardous locations. This requirement is intended to provide additional protection against mechanical damage and to prevent the spread of any potential explosion. Furthermore, all electrical equipment in a Class 1, Division 2 location must be properly grounded to minimize the risk of electric shock. Grounding provides a path for fault current to flow back to the source, tripping a circuit breaker or fuse and energizing the circuit. When selecting electrical equipment for a Class 1, Division 2 location, it is crucial to carefully consider the specific requirements of the NEC and to choose equipment that is specifically designed and approved for use in such locations. The equipment should be marked with the appropriate class and division designation to indicate its suitability for the intended environment. It is also important to ensure that all electrical work in a Class 1, Division 2 location is performed by qualified and experienced electricians who are familiar with the NEC requirements for hazardous locations. These electricians should be trained in the proper installation and maintenance of explosion-proof and intrinsically safe equipment and should be able to identify and address any potential hazards. In addition to the electrical requirements, it is also important to consider other safety measures for a room containing a sewage tank and pump. These measures may include installing a gas detection system to monitor the concentration of flammable vapors, providing adequate ventilation to prevent the accumulation of vapors, and implementing procedures for responding to leaks or other emergencies. Regular inspections and maintenance of the sewage tank, pump, and exhaust fan are also essential to ensure their continued safe and reliable operation. These inspections should include checking for leaks, corrosion, and other signs of damage, as well as verifying the proper operation of the exhaust fan and any other safety equipment. Furthermore, it is important to provide training to all personnel who work in or around the sewage tank room on the potential hazards and safety procedures. This training should cover topics such as the properties of flammable vapors, the operation of the exhaust fan and gas detection system, and the procedures for responding to leaks or other emergencies. By taking these precautions, it is possible to minimize the risks associated with a sewage tank room and to ensure the safety of personnel and property. In summary, the determination of whether a room containing a sealed sewage tank and pump is a Class 1, Division 2 location depends on the potential for flammable vapors to be present. Given the possibility of a tank leak and the potential failure of the exhaust fan, it is likely that the room would be classified as a Class 1, Division 2 location. This classification triggers specific requirements for electrical equipment wiring and installation, as well as other safety measures to minimize the risk of ignition and ensure the safety of personnel and property. The National Electrical Code, specifically Article 500 and subsequent articles, provides detailed guidance on the requirements for electrical installations in hazardous locations, including Class 1, Division 2 locations. It is essential to consult these articles and to seek the advice of qualified electrical professionals to ensure compliance with all applicable codes and standards. The area classification is a crucial first step. This involves a thorough assessment of the environment to determine the likelihood of flammable gases or vapors being present in sufficient quantities to produce explosive or ignitable mixtures. The classification process considers factors such as the properties of the materials handled, the design and operation of equipment, and the ventilation provided. Based on this assessment, the area is classified into different zones or divisions, each with specific requirements for electrical equipment and wiring. For Class 1 locations, which involve flammable gases or vapors, the divisions are defined as follows. Firstly, Division 1, a location in which ignitable concentrations of flammable gases or vapors exist under normal operating conditions, or a location in which ignitable concentrations of such gases or vapors may exist frequently because of repair or maintenance operations or because of leakage, or a location in which breakdown or faulty operation of equipment or processes might release ignitable concentrations of flammable gases or vapors, and might also cause simultaneous failure of electrical equipment. Secondly, Division 2, a location in which ignitable concentrations of flammable gases or vapors are handled, processed, or used, but in which the liquids, vapors, or gases are normally confined within closed containers or closed systems from which they can escape only in case of accidental rupture or breakdown of such containers or systems, or in case of abnormal operation of equipment, or a location in which ignitable concentrations of flammable gases or vapors are normally prevented by positive mechanical ventilation, and which might become hazardous through failure or abnormal operation of the ventilating equipment, or a location that is adjacent to a Class 1, Division 1 location, and to which ignitable concentrations of flammable gases or vapors might occasionally be communicated unless such communication is prevented by adequate positive pressure ventilation from a source of clean air, and effective safeguards against ventilation failure are provided. In the case of the sewage tank room, the possibility of a leak from the sealed tank introduces the potential for flammable vapors to be present. The exhaust fan is intended to prevent the accumulation of these vapors, but its potential failure must also be considered. Therefore, a Class 1, Division 2 classification is likely appropriate. Once the area classification has been determined, the next step is to select electrical equipment that is suitable for the specific hazardous location. The NEC specifies detailed requirements for the design, construction, and testing of electrical equipment for use in hazardous locations. This equipment is designed to prevent the ignition of flammable gases or vapors, either by containing any potential explosion within the equipment enclosure or by limiting the energy available to prevent sparks or hot surfaces. For Class 1, Division 2 locations, several types of protection techniques are permitted, including firstly, explosion-proof enclosures. These enclosures are designed to withstand an internal explosion of a flammable gas or vapor without igniting the surrounding atmosphere. They are constructed of heavy materials and have tightly fitted joints to prevent the escape of hot gases. Secondly, intrinsically safe systems. These systems use low voltage and low current circuits that are incapable of producing a spark or thermal effect that could ignite a flammable gas or vapor. They require specially designed intrinsically safe equipment and wiring. Thirdly, non-incentive equipment. This equipment is designed to not produce sparks or hot surfaces that could ignite a flammable gas or vapor under normal operating conditions. It is typically used in Division 2 locations where the risk of ignition is lower. Fourthly, purged and pressurized enclosures. These enclosures are filled with a clean, inert gas such as nitrogen to prevent the entry of flammable gases or vapors. They require a constant supply of clean gas in the system to monitor the pressure within the enclosure. The selection of the appropriate protection technique depends on the specific application and the characteristics of the flammable gases or vapors present. Factors to consider include the cost, size, and complexity of the equipment, as well as the maintenance requirements. In addition to selecting suitable electrical equipment, it is also important to install the equipment in accordance with the NEC requirements. This includes using the correct wiring methods, grounding techniques, and sealing requirements. Wiring in Class 1, Division 2 locations must be installed in rigid metal conduit or in cable with a gas-tight continuous metallic sheath. This provides mechanical protection and prevents the escape of flammable gases or vapors. All conduit and cable entries into explosion-proof enclosures must be sealed to prevent the passage of flammable gases or vapors. Sealing fittings are used to create a gas-tight barrier around the conductors. Proper grounding is essential to minimize the risk of electric shock and to provide a path for fault current to flow back to the source, tripping a circuit breaker or fuse. All electrical equipment in Class 1, Division 2 locations must be properly grounded in accordance with the NEC requirements. Regular inspections and maintenance are essential to ensure the continued safe operation of electrical equipment in hazardous locations. Inspections should include checking for damage, corrosion, and loose connections, as well as verifying the proper operation of protective devices such as circuit breakers and fuses. Maintenance should include cleaning, lubricating, and replacing worn or damaged parts. Any repairs or modifications to electrical equipment in hazardous locations must be performed by qualified personnel who are trained in the specific requirements for these locations. It is important to keep accurate records of all inspections, maintenance, and repairs. These records can be used to track the performance of equipment and to identify potential problems before they become serious. Training is essential for all personnel who work in or around hazardous locations. Training should cover the hazards associated with flammable gases or vapors, the requirements for electrical equipment and wiring, and the procedures for safe operation and maintenance. Personnel should also be trained in emergency procedures, such as how to respond to a leak or fire. In addition to the electrical requirements, it is also important to consider other safety measures for the sewage tank room. These measures may include, firstly, ventilation. Providing adequate ventilation is essential to prevent the accumulation of flammable gases or vapors. The exhaust fan should be sized to provide sufficient air changes to remove any potential leaks. Secondly, gas detection. Installing a gas detection system can provide early warning of a leak. The system should be designed to detect the specific flammable gases or vapors that may be present. Thirdly, fire suppression. Installing a fire suppression system can help to control a fire in the event of a leak or other emergency. The system should be designed to suppress the specific types of fires that may occur. Fourthly, signage. Posting warning signs can alert personnel to the hazard associated with the area. The sign should clearly identify the area as a hazardous location and provide information on the precautions that should be taken. Fifthly, access control. Limiting access to the area can help to prevent unauthorized personnel from entering and potentially causing a hazard. In conclusion, determining whether a room containing a sealed sewage tank and pump is a Class 1, Division 2 location requires a careful assessment of the potential for flammable vapors to be present. If the possibility of a tank leak and the potential failure of the exhaust fan exist, then a Class 1, Division 2 classification is likely appropriate. This classification triggers specific requirements for electrical equipment, wiring, and installation, as well as other safety measures to minimize the risk of ignition and ensure the safety of personnel and property. The NEC provides detailed guidance on the requirements for electrical installations in hazardous locations, and it is essential to consult these articles and to seek the advice of qualified electrical professionals to ensure compliance with all applicable codes and standards. Remember, safety is paramount when dealing with hazardous locations.